Okay, we'll get it. All right, y'all. Let's do pre-6-2. Okay. Let's get some review in. And I want to see what y'all remember. Number 1. Convert 4 cubic yards to cubic feet. 4 cubic yards to cubic feet. Number 2. Find the circumference of this circle that has, there's your center, it's cutting right through it, and the diameter is 12 inches. Yeah, 12 inches, pretend. Number 3. Yep, we can do this. Let's say you've got an equilateral triangle with a radius of 4 square root of 3. Please see if you remember how to find the perimeter and the area. Perimeter and the area of a regular triangle. There, just to remind y'all. And then last one. Find the volume. A is going to be this box type figure. And this side is 8 meters. This side is 6 meters. And this one is 3 meters. We'll zoom in so you can see that. Okay. And then for B, because I think you'll remember this, also find the volume of this cone. See if you remember that. And it's got a height of 7 meters and it's got a radius of 4. Okay, see what you can do with that. Simply efforts to help you not lose. I'm trying to get some of this stuff to go into long-term memory. Keep reviewing your notes. I'm gonna stop and let y'all have a minute to work. It's annoying. Little hint, just in case you've gotten rough on it, crew. If you've got a 30, 60, 90, just a reminder that the setup is this, like say your X is opposite the 30-degree angle. Remember that your hypotenuse, you would multiply by 2. So it's going to be 2 times whatever X is. And then to get to the long side, which is opposite 60, you would multiply by square root of 3. So whatever X is times square root of 3. That may help you for number 3. Little reminder. Okay, so let's see how you all did. More fun on the board, but since we're missing people today, I'm gonna go ahead and do it all on paper, okay? So we're gonna convert the 4 cubic yards, and I'm gonna do the Saxon style and take that cubic yards and write it as yards times yards times yards, okay? Now let's use our conversion unit. 3 feet equals a yard. We want the yards to cross eliminate. So put the 3 feet in the numerator and the 1 yard in the denominator. And again, we need this to happen 3 times. So 3 feet over 1 yard, 3 feet over 1 yard. Okay, so yards cross eliminate. Okay. And so you basically got ones across the denominator. So let's focus on the numerator. It's going to be 4 times 3 times 3 times 3. What'd y'all get? What was it? 108. Good job. And now feet times feet times feet is feet cubed, or 108 cubic feet. If you got that, good job. And if you didn't, it's okay. Just remind yourself and learn from it. Okay, again, not to trip you all up, just kind of reviewing for stuff we're going to have today. Circumference is either pi times the diameter, or, and remember, circumference is the distance around a circle, or circumference is 2 pi r. So since we had diameter, you probably use the first one. So if you put 12 in for D, pi times 12 is going to be 12 pi inches. If you got that, pat yourself on the back. Good job. Okay, questions on number 2. Okay. This is, again, just trying for y'all not to lose skills. To find, well, in finding, yeah, we got to get around for this perimeter. And we're going to find the area. So we need to find the apothem. Okay, we're going to need to find the apothem for the area. I'll try to make sense here in a minute. And we need to find this distance right here to help us find the perimeter. It kind of all goes together. So what am I trying to say? Okay, I'm gonna back off. Where would one of you all start? What was your plan of attack? Did anybody go ahead and think about it as, and we didn't have to do this because if it's equilateral, you know, each of these is 60 degrees. But let's say you forgot that an equilateral triangle has 3 60-degree angles on the side. Let's think about dividing it up this way. Okay. What is 360 divided by 3? 120. So you know each of these on the interior is 120. And if we break this 120 up into 2, what are each of these? If this whole thing is 120 and it's cut in half, what's this? 60. Yeah. And this is 90 because we dropped a perpendicular for our apothem. And again, you didn't even have to do that if you remember that each one of these is 60 and we've cut them in half. So if this is 60 and it's been cut in half, it's 30. So either way you go, you've got a 30, 60, 90, which is why I reviewed this over here. Okay, stay with me. We need to start with our 30-degree side. Okay, that will give us our apothem. Do you remember what we do to go from the, no, let me back up. They've given us the radius, which is 4 square root of 3. It's opposite the right angle. So what also is it? Hypotenuse. The side opposite the right angle is the hypotenuse. Now, how do we go from hypotenuse to the short side on a 30, 60, 90? Be careful. To go from the hypotenuse back to the short side. If we had to go from x and multiply by 2 to get to the hypotenuse, we divide by 2 to go back. So 4 square root of 3 divided by 2 gives us 2 square root of 3. Okay, so this is, the apothem is 2 square root of 3. Now, y'all, stay with me. To go from the short side to the long side, opposite 60, what is that? Short side to long side. Come on, guess. I think you know. Yeah. So Avery just said it. We're going to multiply the short side by square root of 3 to get to the long side. Now, what is 2 square root of 3 times square root of 3? 9. Well, and back up. What's square root of 3 times square root of 3? 3. Or the square root of 9 is 3. So either way, you're getting that 2 times 3 is 6. Nice. So this section right here is 6. Whew, if you got through that, good job. So let's back up. Perimeter. If this is 6, you all, what's this whole side? 12. And then this is 12. And what's this side? So what's the perimeter of the whole triangle? 36. You got it. So we've answered that. And now let's go ahead. The area of this perfect triangle is 1/2. Let me back up. Area is 1/2 the apothem times the perimeter. What's your apothem again? We found it. Short side, 2 square root of 3. And your perimeter, we just said, is 36. So crew, your 2's cancel out here. 36 times square root of 3. There you go. 36 square root of 3. Y'all can't see it. Sorry. 36 square root of 3 units squared. If you got that, good job. Really, really, really good job. Did it ring a bell? Like, did it kind of come back? I hope. If not, goodness, get on Zoom. I'll reteach it. You'll get it. Okay, hang in here with me. Now let's find the volume. This is newer stuff. The volume, is that the outside or is that the inside? Like what it holds? What is it? What it holds. Yeah, the volume is what it holds. Like if you're working for a shipping company and you want to like maximize how much you can fit in a box, then you care about the volume. It is area of the base times the height. So, Samuel, how would you find the area of the base for this one?
8 times 6.
Tell you what, think about, you could if you flipped it that way, but let's go ahead and look at the bottom. Yeah. And again, you're going to get the same answer as this, and maybe this is a good way to prove it. So let's say the base is the bottom. It's going to be 6 times 3. And assuming that, what is your height now, Samuel? 8. Good job. And with that, clear. What did you get? There you go. Nice job. And remember, meters times meters times meters is meters cubed. You don't have to put the meters, just don't forget the cubed. So again, Samuel looked at it a little bit different for his, but you should still get 44 meters cubed. So nice job. Okay. What's the only difference in the formula for the cone? Who remembers that? A third. Good job, Avery. So for a cone or a pyramid, it's 1/3 the area of the base times the height. I gotta get this down. Okay. Baron, will you help me with this one? Oh, okay.
It's the area of the base. 28, 27. Then do you need help at the door, or what do you mean? Yeah, just take the normal elevator and stairs.
Okay, I'm gonna go ahead. We'll show it to him later. So how do you find, again, you can just remember this, but how do you find the area of this base? Don't remember? The area of a circle is pi r squared. So if you forgot that, pi r squared gets you the area of the base. Amelia, what are we gonna put for the area of this base?
So was there, so I don't think it's right.
Okay, hold on. Substitute it into this right here. The area of this, it's gonna be pi times
5 times 4.
squared.
Yeah.
Good job. Baron, Bennett can catch up on this later. The area, good job, Amelia. The area of this base is going to be pi times the radius is 4 squared. So we put that right there. And actually keep going. You're doing good. What's the height of this? 7. Okay. So once you put all that in, it gets kind of ugly. So if you got approximately 117.3.
Okay, I gotta have 117, but I didn't get the.
Yeah, if you went to the 10th place, but I didn't specify, so you're good. There you go. Who got that? Yay. Okay. If you didn't get it, do you understand what you missed? Because the main thing, I want you to learn from it. Hey, Bennett. Okay. This is all getting recorded, so you can watch it later to get it. So there's that. And now we are getting ready to start. Questions on that before we go to the new stuff? Okay. Okay, y'all. So, whereas before, we were concerned with how much was being held, Now we're going to be looking at surface area. Just to sum that up real quick, we are going to be more concerned about the total area of a three-dimensional object, okay? Like the printing. What's it going to cost us to print the total surface of this package, okay? Surface area. So let's go ahead and get that down in your notes. 6.2 is over the surface area of prisms. And cylinders. Surface area of prisms and cylinders. Okay, let's review some of this. A prism. That is a polyhedron. I know we talked about this the other day, but review doesn't hurt. A polyhedron with two congruent parallel bases. Now, polyhedron, that's 2D or 3D? 3D. 3D. And as long as all the faces are polygons, it classifies as a polyhedron. So I was trying to think like a soccer ball. What's a soccer ball made of? All the different shapes around it. Hexagons. Okay. So that's a 3D polyhedron. Would not be a prism because it doesn't have two parallel bases. I don't think. Yeah. It would fit as a polyhedron, but a prism is more along the line of something like this. Okay. That's got the two parallel bases here and here, for example, could be considered bases, or this and this. Those could be considered bases, or even this and this. Okay. But the point is it's got two parallel bases. Cylinder. Okay. I need to back out some more. Cylinder has two parallel bases. Okay. So that's how we're kind of limiting on that. So let's go ahead and put that. Cylinder just basically has circular bases. Turn to, when you get that down, cylinder has circular bases. Turn to page 309. We're going to look at some of these. Okay, I think we've talked about this before. We know there's the base, there's the base. Along the front and sides, these are your lateral faces, okay? Here's the base on this one, here's the base on this one. What shape are the lateral faces on B? Okay, let me back up. What shape are the bases on B? Y'all see that? Triangles, yeah. So this is a triangular prism. These bases are rectangles. This is a rectangular prism, and I know you've already seen the answer, but the base on this one it's a perfect octagon. It's an octagon. It's a prism with octagon bases. I am not getting this today. Oh, octagon bases. So you might have one in your homework where you're going to name what type of prism it is, but there you go. Okay, now, but look at B. What is the shape of the lateral faces? Can y'all tell that? Yeah, so even though this is a triangular prism, the lateral faces on the side are all rectangles, okay? Same thing over here. The base is an octagon, but the lateral faces are those really long, narrow rectangles, okay? Look down a little bit further because I'm not going to make you draw all this. Notice this one on the far left is a right prism. All the sides are right angles. Same thing here. It's turned on its side, but can you see, like, what are the shapes On the middle one, what kind of bases are those? What are they? I think they're, yeah, they're quadrilaterals, but I do think they're trapezoids. Okay, so trapezoidal prism. And notice again, this is a right one because with the base, the lateral face is at a 90-degree angle. So these are right prisms. The one on the right, however, see how that's an oblique prism? We're going to have to find the altitude on the outside of it. Okay, so be careful on those. Okay, we're going to draw these in a minute, but I forgot the box. That's what I was looking for earlier was the box I was going to use. When you've got a shape like this, to be able to work these, you're going to need to think of taking it apart to find the whole surface area. And we're going to be finding the area of this base, the area of this base, and then we're going to be getting the lateral base, okay? So instead of finding the area of A, the area of B, the area of C, and the area of D, we're going to clean that up a little bit and streamline it, okay? So notice if we get this box and we spread it out, and I'm just looking at the lateral area here, okay? What is the combination of the lateral area for the base? Okay, let me put it another way. Okay. Sorry, y'all. I don't know how to make this exciting. Let's say this is what we're looking at. Okay. And let's say the blue or purple is going to be our bases. What is the distance all around this base? If we look at it as a whole, what is it? If we take this distance plus this distance plus this distance plus this distance, the total is our perimeter. Okay. So again, they have spread it out, but we're going to be using the perimeter of the base to help us so that we don't have to do as many calculations. Okay. So remember that if this net is divided up and spread out, the whole base is the perimeter of this. Now let's go. Let me get that out of the way. For your notes. Sorry, y'all, this is a hard one to teach. Okay, 3D. Remember. Mess it up. Area of base. That's your B. That's the area of the base. Remember for your notes that this is a lateral face. So when we're talking about the lateral, you need to know those are the sides and the bases are the bottom. And when you see the big B, remember that that is the whole area of the base. Remember this edge is the height. Okay. And if we break this up, we tear this box apart, then it's going to look something like this. Remember the net where it becomes two-dimensional. So here's a base, here's a base, and all this across here, this is going to become our lateral area right here. We're not going to break it up and do individuals. We're going to find this whole area for the lateral. And how we do that, okay, let me back up. I really was organized before I got here. Know that the lateral area is the sum of the areas of the lateral faces. Okay, so this is a lateral face, lateral face, lateral face, lateral face, but the lateral area is the sum of them all. Okay, and know that when we're finding the surface area, Do I need to wait? I think when I get nervous, I go faster. Okay, I still see y'all writing, so I'm gonna try to slow down. Okay, so to find the surface area of a three-dimensional figure, we're gonna find, or rather, it's gonna be the sum of the lateral area and the two bases. So the full surface area will be the lateral area plus the area of the two bases. Okay, so to get the lateral area, and we're going to break this up a lot today, the lateral area is going to be the perimeter times the height. So this is the perimeter. Okay, it's all of this. Actually, maybe I should draw that there. The perimeter is all the way across. Think of like your base in a way, but that's the perimeter. And then the height, I'll do that in gray. There's your height. Okay, so the lateral area, you're going to be finding the perimeter of the base, and then you're going to be multiplying it by the height. Oh, goodness, this is going too fast. Okay, once you find the lateral area, then the surface area is going to be the lateral area plus 2 times the base. So the surface area is going to be finding this whole lateral area, and then you're going to be adding the two bases to it. Okay. Now, this is such, I don't want to say this. For bonus points, if anybody wants to write these equations 20 times each, internal min, I'll give you 10 bonus points. Okay. Write that 20 times each, write that 20 times each, internal min to me, I'll give you some bonus points. Get them in your head. Okay. Now, the easiest way I know how to do this is we're just going to jump in and do some. So can I keep going? Okay. Let me pass these out. Not bad. I don't feel like I'm doing a great job explaining it. But it's really not bad. And these are so practical. I mean, any of y'all could go into business later and actually do this directly apply another. There you go. You're welcome. Okay, so some of these I'm going to do with you. Go ahead for our purposes here and label this first section example 1. So it will match our notes. The second section, label example 2. And then this lower section, example 3. And that way you'll know how we're matching things up exactly. Okay, so for some of these, notice they just want the lateral area of the cylinder to the nearest tenth. Okay, so just a reminder, I need you to visualize this. They don't want the bases. They just want this side part. What's the area of the side? That's what we're going for first. So for example 1, and we are using, this is as much for me as you all, 6-2 mixed worksheet for this. Okay. We are finding, you all know that LA means lateral area at this point, right? We're finding the lateral area of each cylinder. to the nearest tenth. Okay, let's start off with this one right here. You got your cylinder, that's the best I can do. It is 6 meters tall. The radius is 4 meters. And again, the reminder here is we are just getting the lateral area, not the top, not the bottom, just the sides. So the lateral area is the perimeter times the height. Y'all remind me how we get the perimeter of this. Circular base. What's that perimeter? What is around a circle? That's a circumference. So the perimeter for a circular base is the circumference. So what you're going to do there is 2 pi r for the perimeter. And in this case, what's our radius?
Did you say not to do it on the sheet?
You actually can do it on the sheet, but I want to look for this in your notes. We'll move over in a minute and I'll let you try a couple on the page. So put number 1, I'm making this one up in your notes. So your perimeter for a circular base is going to be 2 pi r. Our radius is 4. So this is 2 pi times 4. Okay. Now what's the height of this one? You got 6 meters. And these are meters too. Okay. Now I did not explain this well. I feel like I'm butchering this lesson. For a cylinder, if you did a net for it, it's going to look like that, right? You fold up the top, fold down the bottom, and that circular part, if you spread it out, becomes a rectangle. But still, that length right there is going to be 2 pi r. Okay, if you put it back together, still makes a circle. So anyhow, 4 times 2 is 8. 8 times 6 is 48 pi meters squared. So we're going to leave it in pi just to save time. Okay, good on that? So to get it in your head, go back to your worksheet over here, and I want you all to try number 1. You're just finding the lateral area. Take a second and do that. Again, lateral area is the perimeter times the height. So try number 1 on the paper. You can actually do it on the worksheet. Uh-huh. Can you see that? Okay. I think your eyes are better than mine. Okay, now I'm gonna go back in. Lateral area is the perimeter times the height. So first of all, we've got circular bases. How do I find the perimeter of this circular base? Circumference is either 2 pi r or circumference is what? Pi d, diameter times the pi. So in this case, we've got the diameter is 10. So what am I going to put for the perimeter, which is actually the circumference in this case? Y'all tell me, I'm not saying it. pi times 10. Thank you, Samuel. So 10 pi. Okay. Now, what is the height? I'm trying to give you a hint right there. 2. Okay. And you see that's going to give us, because like here's your base, here's your height. That's giving us the lateral area right there. Okay. So if you got 20 pi, which is approximately what? 62.8 centimeters squared because it's area, then you got it right. Good, bad, ugly? Okay, I want you solid on the lateral area. Move over and try number 4, please, real quick. And put a check mark on that. You got it right if you got 62.8. Now take a minute again. Lateral area is the perimeter times the height. We have circular bases again. So for the perimeter, you're going to use circumference, either 2 pi r or pi d. Take off. Okay, I'm guessing. I don't want y'all to freak out, okay? Baron, how'd you get the perimeter of your base?
Before. Oh, I was solving it.
Say it again.
I was solving it.
Oh, okay, it's okay. The perimeter of the base is going to be the circumference. How do I find the circumference? If circumference is 2 pi times the radius. 2 times the pi. Yep, 2 pi times 3. Good job. And now what is the height? 6. Good job. Okay, so again, he got the circumference there. Here's the height. So essentially, we're finding that right there, just the side part. So 2 times 3 is 6. 6 times 3 is 36. I'm seeing 36 pi, which if you put it in your calculator, Baron, do you want to finish that? What does 36 pi give you on your calculator? Rounded to the 10th place.
Second, I currently don't have my calculator.
Oh, never mind. I'm sorry. Okay, let me, somebody else help me. Who got it? Okay. Yay, I heard several people. 113.1 meters squared. So if you got that, good job. Okay. Y'all feeling better about finding the lateral area? Okay. And again, if you have, never mind, we're going to find it down here. Now let's move on. Example 2. Example 2. This time, and again, this is not on your worksheet, put this in your notes. Oh, please let me draw this well. And please tell me I'm recording. Okay. It's not the best, but it's better than nothing. How would you all classify this one? If you were to name the shape, what would it be? Triangular prism. Good job. I am not giving you an octagon. I could not handle that one. This time it's 3 centimeters for this side of the base, 4 centimeters for this side of the base. They don't tell us, but then they give us the height is 6 centimeters. So 3, 4, 6 centimeters. Okay. The directions this time are find A, the lateral area, and B, find the surface area. Okay, so we're going to start with A. The lateral area is what? The perimeter times the height. Okay, so we've got to start off finding the perimeter of this triangular base. So we're not just finding this, well, yeah, let me back up. Talk right. We've got to find the perimeter. Do we have everything we need for the perimeter of this base? No, we don't. Now, quickly, this looks like I just forgot what they're called. A Pythagorean triple. Pythagorean triple. Do y'all know if you got a 3 and a 4, what the last one is? It's a 5. Okay, this is 5 centimeters. If you don't know that, quick reminder, you can do a squared plus b squared equals c squared. Put in 3 and 4 and it will give you 5, but we're not going to take the time for that right now. So the perimeter then is going to be 3 centimeters plus 4 centimeters plus your 5 centimeters. Okay, we'll add that up in a minute. So that's going to give us the perimeter of this. Now, what's the height? 6. Okay, crew, let's figure that out. 3 plus 4 is 7. 7 plus 5 is 12. 12 times 6 is 72 centimeters squared. Did y'all get that part? Good on how we did that? Okay. Tell me if you're not, I will try again. Now the surface area is going to be the lateral area plus how many bases do we have? Say it out loud, y'all. How many bases? 2. You got it. So it's 2. I did this different in another class and it's hard to come back. The capital B, remember means area of the bases. So we've got the lateral area. What was it? 72. Okay, we got the sides. Now we need to focus on getting the area of the 2 bases. So it's 2 times. Now, what's the area of a triangle? You got it. 1/2 the little b times the h. And it just so happens they've been so nice, y'all, to give you this lovely little right triangle with this being 4 and this side being 3, and it's a right angle. So we've got our base, we've got our height. So it's just going to be 2 times 1/2, 3 times 4. Okay. So what's 1/2 times 2? 1, and 1 times 3 times 4 is 12. Good job. So y'all, what is 72, your lateral area, plus the 2 bases area? Add them together, what do you get? Man, I must be putting y'all to sleep. Come on, y'all, 72 plus 12. Thank you. 84 square centimeters. And that is the whole kit and caboodle. That's not just the lateral area, it's also the area of the bases. It's the whole thing. Okay? I know we're pushing time, but I want you to try one of these before you go. Would y'all please, based on this, do number 9? You can work it out to the side, that's fine. But try number 9. A, find the lateral area and then circle that answer when you're done. Then B, find the surface area and circle or box that answer. Give it a shot. I want you to try it. Number 9, based on what we just did. Did everybody get example 2? Okay. What are y'all going to have to use on number 9 to get started? Pythagorean theorem, okay? They give you the hypotenuse and they give you one leg. So if you're having trouble with that, work with me, but if you know how to do it, just keep trucking. Pythagorean theorem, a squared plus b squared equals c squared. We have one side, so you can put that in for a, that's going to be 6. We don't know the other leg. Ooh, I messed that up. So just leave it b. But we do know the hypotenuse, which is opposite the right angle, so that's going to be 10 squared. So when you substitute those in, you should get 36 plus b squared equals 100. Subtract 36 on both sides. You get b squared equals 64. Square root both sides to get rid of the squared. And if you got that other leg is 8, you are correct. Now you can do your perimeter. Don't forget the Pythagorean theorem. So much of this stuff just keeps coming back. I'm having a terrible time gauging if this is hard or easy for y'all. Amelia, would you tell me, we're getting the lateral area, we're getting the sides first. How'd you find the perimeter for that? Or what did you get?
Like my answer on A?
Well, just tell me the perimeter. What'd you get?
Uh. Remember, I got 24. I'm trying to. Can I tell you the answer I got to make sure I'm doing the right thing? Because
What'd you get for the lateral area?
216.
Yeah. Okay. So tell me what you got for the perimeter. This
There's a lot of
edge plus
numbers.
this
You know,
edge
it's
plus
not
this
so-
edge.
There's so many numbers on my paper right now that I'm trying to remember where I wrote the lateral.
Okay, okay.
The Pythagorean theorem. So it was like 6 plus 10 plus 8 times 9.
Okay, hold on. So your perimeter was the 6 plus the 8 plus the 10, and you should have gotten, what was that, 24?
Yes.
Good. And what was your height? 9. Okay. 6. I'm double checking this. Yep, 24. And 24 times 9 should have given you 216 millimeters squared. Y'all good on the sides? Okay. Now let's find the surface area. Good job, Amelia. That's going to be the lateral area plus twice the area of the bases. So we've got the lateral area, that's 216, but now we've got to get the area of a base. I'm out of room, so I'm going to have to do it over here. The area of one base, and what kind of shapes do we have for our bases? Triangles. And to find the area of a triangle is 1/2 the base times the height. Now, again, these are right angles, so this is pretty easy. What is, Avery, what is your base for this one? Little b. Okay, hold on. I'm going to try to spell this out. If this is 10 and this side is 8 and this side is 6, what's your base? No. This base is 8 and this is going to be the height. Now, again, that's two-dimensionally. So yeah, it's going to be 6 times 8, which is 48. And 1/2 of that is 24. But this one's 24. This one's 24. We've got 2 of them. Does that make sense? Okay. So This is 48. 48 plus 216 is if you got 264, you are correct. Good on that? Okay, get on Zoom with me tomorrow and I will go so slow through these if that helps. But that's number 9. Okay, one more before you go. I'm gonna hold you just a couple minutes extra. And then you can stay after for a few minutes if you need to. But I want y'all to get this. It's not as bad as it looks. Okay, example 3. Example 3. Okay, kind of a long cylinder. This time the radius is 5 feet. We've got a height or a length of 24 feet, however you want to think about it. And this time, all they say is find the surface area. So they may not tell you first that you got to find the lateral area, but you know that for the surface area of a cylinder, it's going to be the lateral area plus the area of both the bases. Okay? You want me to give you a minute, just let you try? You've got the tools. And if it helps, this is actually number 15. Tell you what, go ahead and do this in your notes. Do it in your notes. And then later, because there's only 3 of these examples, see if you can remember how to do it on your worksheet when you do your homework. Okay, do this in your notes. Let's go ahead and find lateral area. Lateral area is the perimeter times the height. So look at your base. What is the perimeter of the base, Bennett?
2 mile or 2 pi 5.
Okay, 2 pi times the radius, which is 5. Good job. And while you're at it, Bennett, what's the height of this whole thing? 24. Good job. And again, that's giving us this right here. It's giving us this outside part right there. So that's going to be 10 pi times 24. I'm just going to say 240 pi because that's easier to work with right now. Okay, you've got the sides. Now let's look at the area of the bases. So, okay. Let's do the area of one base. Circular base, pi r squared. So what's your radius again? 5. So it's going to be 5 squared. So your base is, one base is what? 5 squared is? And 25 times pi is 25 pi. Okay, so let's take everything and put it in. Who wants to help me with this to wrap it up? Allie, help me. Okay, lateral area. It's lateral area plus 2 times the base. What is my lateral area, Hallie? 240 pi plus 2 times, what's the area of one base? 20. Good job. And so, Samantha, when you put all that together, 240 pi plus 50 pi, what'd you get?
In terms of pi or?
Pi.
295.
Good job. But on number 15, oh, they did want it in terms of pi. We can stop. Good job. Feet squared. Don't forget your unit. Okay. What do y'all think? Is it, if this is like awful, terrible, and this is, it's actually pretty easy. Where you? Oh, I'm seeing some thumbs up. What about the rest? Okay.
Worse than it.
Okay, sorry. Okay, Bennett's down here. But for everybody else I saw here up to here. So that's encouraging. I was thinking you all would absolutely think it was the worst thing ever. So that actually encourages me. Okay, for today, finish that worksheet. Practice 6-2 mixed, finish. So essentially that's going to be all of them 1 through 15. For Tuesday, again, gonna kind of push you a little, but I think you can handle it. It's not in number. It just kind of makes you sure you got the concept. Do 1 through 15 odd, and then 21 to 25 odd. Again, not bad. I'll probably have you practice some more later, but that's it. So there's not many, but you have to think a little bit more on them. My caution is pay attention, especially on 11 and 13. Don't get yourself tripped up. Those hints before you go. Notice 11 before, hold on. Before you freak out about finding the area of that base, which you all could do, notice it's only asking for the lateral area. So that might not be as bad as you think it is. And for 13, I want you to notice on 13, they give you one measurement in millimeters, another measurement in millimeters, but then they ask you about square centimeters. So get on the same page with your units and you shouldn't have a problem with it. Okay. That's it. Have a good one. Yes. Thank you. Homework. Now, I did give Algebra 1 a little bit more time because we're still getting in the groove. So if you need to get on Zoom with me and ask me some questions, that's fine. But if you're done with it and you just want to take a lesser homework grade, go ahead and put it in the grade folder.
And this was my home from last week that I left at home.
Thank you.
Do you want me to put it somewhere
Yes,
separately?
yes.
Or
No,
for-
just go ahead and put it in here. I'm not organized yet, so be happy, and I'm not counting anybody late at present.
It turned out I
Oh.
had it in Avery's backpack.
Ah, okay. I meant to get y'all's folders out of my old van. Thank you. Are you feeling better? Mostly?
Mostly.
Okay.
I still have a stuffy nose and a cough, but Mom does too. We were both sick.
It